For greenhouses of a bell pepper grower on a stunning 125 hectares in the Netherlands, VYNCKE installed a highly efficient biomass energy plant. In combination with the existing geothermal energy plant, these two biomass heaters will help them to reduce their energy costs and their carbon footprint.
We choose a solution out of our CNS range where we can combine hot water, superheated water, CO2 or even chilled water as an energy carrier. We make this a future-proof solution, meaning that later on we can adjust emissions when they become more strict. We can add CO2 stripping or even chilled water when needed.
The CNS hot water boiler consists of three main parts. 1. The DWS water-cooled step grate. 2. The water-cooled combustion chamber. And 3. The vertical fire tube heat exchanger. Let's see inside the combustion chamber. Biomass fuel consists mostly of forest residues, tree roots, tree stumps, and prunings. They are burned with temperatures around 1000 degrees Celsius, hence the need of water cooling for protection and for a higher combustion efficiency.
Here we are at the water-cooled section of the grate. Between each water-cooled step, you have an air-cooled pusher plate. This plate will push the fuel from one step to the next, as well as feeding the primary air, which can be preheated up to 200 degrees to ensure efficient combustion, even with high moisture fuels. As we come up from the grate, we have flue gas recirculation vents. These will recirculate flue gases in order to cool the combustion room without affecting the airflow. And above that, we have our secondary and tertiary air to complete the combustion and ensure compliance with the emission standards.
After the combustion system and the heat exchanger follows more important equipment. There is a flue gas condenser, a bag filter, a flue gas recirculation system, and a SNCR injector.
With stricter emissions regulations, especially for NOx and ammonia, as well as more complicated fuels, our boilers include a series of flue gas treatment technologies in order to ensure that our installations comply with the local regulations. Our boilers are generally WID and BREF compliant, as well as having a 2 seconds residence time in order to ensure full burnout and emissions compliance. With regards to efficiency, we can include for humid fuels and low return temperatures flue gas condensers in order to further improve the efficiency. In this case, we go even a step further and we include a heat pump in order to bring down the flue gas temperatures to below 20 degrees.
Two boilers are fired up and running, and during cold seasons, they can produce up to 40 megawatt of hot water for the greenhouses. The flue gas temperature at the stack is only 20 degrees Celsius. It all starts with the unloading of the biomass.
Here we are confronted with low-grade biomass coming from shredded prunings and roots. We made the choice to go for an overhead crane with a well-defined grip. The crane follows a well-defined pattern to mix all the receiving biomass into a homogeneous fuel. Once that homogeneous fuel is reached, we go to 2 receiving hoppers where we load up to 30 tons an hour of biomass. Let's go to the receiving hoppers. Here we are at the receiving area. The overhead crane is unloading the biomass in the 90 cube receiving hopper, which is actually a walking floor with at the end a spindle which brings the material into the conveyor, which brings it then up to the pusher at the beginning of the boiler.
After being fed into the hoppers by the crane outside, the fuel is transported by means of this chain conveyor to the fuel launch station behind me. Inside the fuel launch station, a hydraulic pusher pushes the fuel, proportional to the capacity of the boiler, onto the grate inside the combustion room. On the energy plant behind me, you can see the combustion room fully integrated in the boiler pressure part circuit. You may remember that inside the combustion room, the walls are lined with refractory lining. This ensures a stable temperature for good combustion. On the outside of the combustion room, we have insulation material that avoids heat loss to the atmosphere and maintains a safe operating environment. Additionally, the blue air ducts behind me bring secondary air into the combustion room in order to complete the combustion. When burning wet fuels, such as the case here in this project, a lot of energy is invested in evaporating the water content of the biomass. The only way to recover this energy is to condense the flue gases. In the condensers behind me, the flue gases are brought down to a temperature below their dew points, which essentially recovers the latent energy and introduces it into the hot water circuit. In order to assure the good lifetime of this equipment, the material choice is of highest importance.
This customer wanted to get rid of fossil fuels and produce CO2 neutral bell peppers. VYNCKE has helped him to achieve that. All the heating needs are now covered with biomass boilers of more than 110% efficiency and with impressive low emissions.